Today we're going to be simplifying mostly radical expressions. This time we're putting both numbers and letters underneath the radical. So this first one, the third root of 27 z to the ninth, we can split this into the third root of 27 and the third root of z to the ninth. So I'm just splitting it up just to give myself more space to see what's going on. The numbers we tackle the same way that we've always been simplifying radicals. Look in your thirds column, see if the number 27 is there. It is. The third root of 27 is 3. Okay. There are several ways to tackle the third root of z to the ninth. Here's the way that they want us to do this. Third root of z to the third times the third root of z to the third times the third root of z to the third. Okay, 3, 6, 9. Do you all see that there are 9 factors of z underneath the radical? I took those 9 factors of z and split it into 3 groups of 3. Each one of these, what is the third root of z to the third? The third root and the exponent of 3 will cancel each other out, leaving you with just z. The third root of z to the third is z. The third root of z to the third is z. So our final answer here is 3z to the third. Now, do you want to write all of that out every single time? That's a lot of stuff to write out. So there's several ways to think about this. If we're talking about a third root, you need groups of 3 because the third root of z to the third will cancel and give you just a plain z. So how many groups of 3 are there in 9? There are 3 groups of 3. So you can do the exponent divided by the index to get the exponent in the simplified form. So say that we were working with like the fourth root of z to the 12th. What would the fourth root of z to the 12th be? How many groups of 4 are there in 12? 3. That would be z to the third. What if it was the fifth root of z to the 25th? How many groups of 5 are there in 25? So that would become z to the 5th. Now, what happens if it's something like the third root of z to the 7th? How many groups of 3 are there in 7? 2 with 1 left over. So let's look at what happens when we have 1 left over. So in number 2, I've got the third root of 8. I've got the third root of r to the third, the third root of s to the 5th, and the third root of t to the 10th. So my first step is just take all of the stuff that's under the radical and spread it out so you have a little bit of room to work and to look at what you have. The third root of 8, that's on my chart. The third root of 8 is 2. Third root of r to the third. How many groups of 3 are there in 3? 1, so that becomes just a plain old r. Okay, here's one of those where how many groups of 3 are there in 5? There's 1 group, but there's a couple of left over. Here's how they want us to write it. They want us to say this is the third root of s to the third times the third root of s squared. The third root of s to the third is s, and then this one stays as the third root of s squared. So those leftovers are still stuck under the radical. Here's a very, very oversimplified, almost childish way to think about it. This thing is a third root prison. In order to break out of a third root prison, you got to have a group of 3. So these 5 s's, 3 of them work together and break out, and there they are right there. The other 2 are left over. They're still stuck in the third root prison. Okay, now I don't know about you, but I am a very visual person. I don't want to have to write all of this stuff because that looks messy and takes a lot of time, but I'm still a visual person. Some people can say there's one group of 3 in 5 and there's 2 left over. It's kind of like division with remainders. 5 divided by 3 is 1, remainder 2. I have trouble remembering all of that, so I like to use a visual helper like dots. If I have s to the 5th, we've got 1, 2, 3, 4, 5. These 3 form this s. These 2 are left over. Those are the 2 that are stuck under the radical. So I use dots to help me organize my thinking so that I know how many full groups of 3 and then how many are left over that are still stuck under the radical. So if I do that with the third root of s to the 10th, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I feel like dots are easier to draw than s's. That's why I use dots, because they're just easier. I have 3 full groups. So that would be t to the 3rd. And then this one's left over, so we still have a third root of t. Once you get all of the pieces simplified, we've got all of this junk here written in green. How the heck do we write our answer? You start with numbers and then letters in alphabetical order, and you do the stuff that's not under the radical first, and then you do the stuff that's still stuck under the radical. So numbers and letters not under the radical in alphabetical order. So we're going to do 2r s t cubed. Then we'll do 1 third root symbol. My gosh. And then we do all of this stuff that's still stuck under the radical. So we've got s squared and t. That is our final simplified answer. Number 3, we have the 4th root of 12, the 4th root of d to the 4th, the 4th root of e to the 9th, and the 4th root of f to the 14th. I'm going to make that 14 super clear. There we go. Start with your numbers, 4 through to 12. Look in your fourths column. Are there any numbers smaller than 12 in your fourths column besides 1? There are not. So this is going to stay the 4th root of 12. We can't simplify that any more than it already is. 4th root of d to the 4th. This time we're looking for groups of 4. How many groups of 4 are there in 4? 1, so that's a plain d. How many groups of 4 are there in 9? There are 2, oops, I'm doing E, not D. There are 2 full groups of 4, and then there's 1 left over. That 1 left over is still stuck under the 4th root. So I like to use dots because I think dots are easier to draw out than a whole bunch of E's. But these are 2 full groups of 4. That becomes E squared. This little guy that's left over is still stuck under the radical. Now, if you are able to think about how many groups of 4 are there in 14? There's 3 groups of 4, that's 12. Then there's 2 left over. So it's f to the 3rd times the 4th root of f. See, I already forgot how many squared. So my short-term memory issues make that method problematic because I forget stuff. So I just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 3 full groups of 4, so that is f to the 3rd. These 2 are still stuck under the radical, so we have the 4th root of f squared. It's a visual way for me to break things up and keep track of everything and not forget anything. For the answer, you would start with numbers that are not under the radical. We don't have any of those. Then you do letters not under the radical in alphabetical order. So d, e squared, f to the 3rd. Then you want to draw 1 4th root symbol. And anything that's under the 4th root, numbers first, then letters in alphabetical order. So 12, what the heck? E, f squared. Number 4, honestly, I would not give you one that looks like this, but do you remember that an exponent of 1/4 is the same as a 4th root? So this is the 4th root of 625, j to the 8th, k to the 4th. Pause the video. This one's like way easier than number 3, but try number 4 on your own from this point. So we've got the 4th root of 625. According to my chart, the 4th root of 625 is 5. How many groups of 4 are there in 8? There are 2, so that's j squared, none left over. How many groups of 4 in 4? There's 1 with none left over. So my simplified answer is 5j squared k. In number 5, we start by splitting this into the 5th root of g squared over the 5th root of h to the 7th. Simplify the top if you can, simplify the bottom if you can. On the top, how many groups of 5 are in 2? None. Those are going to stay stuck under the radical. On the bottom, how many groups of 5 are in 7? 1. So we have h, and then we have the 5th root of h squared. Now, that's our simplified answer, but mathematically, can we leave our answer like that? There's a radical on the bottom. That's bad. So we need to multiply the top and the bottom by something to make that radical go away. We currently have 2 factors of h. How many factors of h do we need for the 5th root to go away? We need 5. We have 2. How many more do we need? 3. We need to multiply by the 5th root of h to the 3rd. You need to complete that group of 5. So you already have 2. You need 3 more. By doing this, you've completed that group of 5. So this thing is now the 5th root of h to the 5th, which is simply h. So what do we have on the top? On the top, we have the 5th root of g squared h to the 3rd. And on the bottom, we've got the original h that we simplified. We've got the second h that we simplified. So we have h squared on the bottom. If you want another one like that, here's another one that you could try that's fairly similar to the problem on the test and the review. What if you had the 3rd root of a squared over b to the 5th? If you want to try that one on your own and check the answer with me later, you can. When I look at number 6, I'm actually drawn to the second term first. I don't know why I'm drawn to the second term, but I see the 4th root of 6x. Is there anything that can be simplified there? The 4th root of 6 can't be simplified. The 4th root of x can't be simplified. So this thing is completely simplified. However, in this first one, I see the 4th root of x to the 5th. So this thing is the 4th root of 6 times the 4th root of x to the 5th. How many groups of 4 are there in x to the 5th? There's 1, and then there's 1 left over. Okay, I drew this kind of funky, but this ends up being 2x 4th root of 6x. So this thing right here, I pulled an x out because there's a group of 4, and then there's 1 left over under the radical. And then we have the original plus x times the 4th root of 6x. Here's what I want you to notice. X 4th root of 6x, x 4th root of 6x. You got 2 of these funky cookies plus another funky cookie. How many cookies do you have? 3 of these funky cookies. That's your final answer. Here's the answer to that extra example I gave you. Your assignment is in Big Ideas Math. It is 5.2 Part 4.